All right, class. So I have a lesson here for tomorrow, which is going to be 11/21/19. All right, teaching point to connect short and long wave radiation with the greenhouse effect. Launch why a greenhouse is useful. All right, so think of an answer, pause it, and when you have an answer, hit the play button. All right, thank you. All right, guys. So why a greenhouse is useful? Well, if you notice here, right, you have you got to connect the glass, of course. So there is some metal here, metal framing, but glass allows for one behavior called transmission. Right, it goes right through the medium. So when you have transmission, light can travel in the greenhouse and then get absorbed by plants. By here, you have these tall vertical plants here. You have some plants on tables. You have the dirt here as well. So they can absorb it. And again, once you're a good absorber, you're a good radiator. And that's why the greenhouse is so warm. All right, because it can radiate that energy out. It gets warmer. All right, so it can keep things that are alive in the wintertime because light comes in, it gets absorbed, and it gets radiated back as heat, what we call infrared. All right, so take out your reference table, go to page 14 for wavelengths. That could be very useful today. All right, so let's get this down, please. Greenhouse gases trap heat. All right, certain gases in the atmosphere behave just like the glass of a greenhouse, allowing incoming shortwave radiation, visible light, through while trapping outgoing long-wave radiation called infrared. All right, very hard for me to draw on my computer, but just hear me out. So the atmosphere can absorb a lot of things, a lot of different types of radiation. Our sun is a medium-sized star. It doesn't give off gamma rays, it doesn't give off X-rays, doesn't give off microwaves or radio waves. It's right in the middle. It gives off ultraviolet, it gives off visible, and infrared, right in the middle of page 14. That's what it gives off. All right, and there is a gas in our stratosphere, which you learned about last year, called ozone. All right, ozone gas is a good ozone and a bad ozone. The bad ozone is at sea level, right? So you can actually breathe that harmful gas in. And there's good ozone, which is in the stratosphere, and that would take in UV radiation from the sun, right? Most of it, absorb it. So that means that a lot of visible comes down to us and a lot of infrared. Now, going here, primary greenhouse gases include, in order of abundance, we have water vapor, a lot of water vapor. We have also a lot of CO2, carbon dioxide. We have a lot of ozone, which is O3. And we have a lot of methane too, right, called CH4, right? That's the symbol of methane. All right. So these gases are like a greenhouse, right? It can actually help keep heat inside a greenhouse, or maybe inside the Earth, or close to the Earth's surface. So we have infrared given off by the sun as incoming infrared, and we have light left over. That incoming infrared, right, can be absorbed by these greenhouse gases. And which means that we really have visible light coming down to us. More visible than anything else. You know, we do have UV. I mean, it's obvious because your skin will change color if you have too much radiation from the sun. All right, and we can also feel the heat as well as infrared coming down to us. All right, next. All right, just getting back to this picture. Incoming solar radiation comes down, transmits through the glass, and then everything inside the greenhouse will absorb it And again, if you're a good absorber, you're a good radiator, right? That's why the heat here is inside the greenhouse. All right, greenhouse effect. Here we go. In the absence of any greenhouse gases, right, also known as GHGs, or outgoing energy, would leave the Earth and would be extremely cold. So without these gases, Earth would just be it would be a very cold desert. All right. Presently, the increased production of GHGs is trapping too much heat, causing the Earth to warm. This results in global warming and a change in the Earth's climate. All right, according to this picture, we have incoming solar energy, 100% coming down to us. All right, and a lot of this can get scattered and reflected. Let's take a look. All right, so 6% can be reflected by the atmosphere. Right, we have a pretty thick atmosphere from the troposphere, we have the stratosphere, the mesosphere, and the thermosphere. 20% reflected by clouds. So if it's a very overcast day, 20% can be reflected by clouds. 4% reflected from the Earth's surface. So sometimes, we can have light color things and we can have smooth surfaces, and 4% of that can get reflected. All right, so according to this picture, roughly 51% is absorbed by land and by oceans. So when this gets absorbed, if you're a good absorber, you're also a good radiator. Notice all the arrows going back up, and it's a different color. It's red, right, which is heat. Okay, so conduction and rising air, 7%. We have carried to clouds and atmosphere by latent heat in water vapor. Latent heat is just a phase change. All right, going from, let's say, condensation to vaporization. 23%. We have radiation absorbed by the atmosphere, right? So this outgoing can be absorbed, right, by that. And if you take a look here at the end, right, so 64% of it can make it up very high into space, right? 6% radiated directly back to space from the Earth. 64% radiated to space from clouds and atmosphere. All right. All right, so when you're looking at this picture, right, we have the sun, we have the sun's rays coming down. This could be in the form of visible, it could be infrared, or it could be as UV. And if you notice, right, it's going to go down, it's going to go past our atmospheric layer, and the Earth will take it in, and eventually we'll give it off as infrared heat. And if you notice, some of this infrared heat can go back into space. If you look here, it can be trapped. So some of this heat can get trapped inside the Earth, making Earth warmer than what it should be. The average temperature for the Earth is 15 degrees Celsius. If you go to page 14, look at your top picture and look at sea level. That is average for the Earth. Right? So if you look at sea level and temperature, it's right there. It's about 15 degrees Celsius. All right, so looking at this picture, most of this radiation is absorbed by the Earth and warms. All right, some energy is radiated back into space by the Earth in the form of infrared waves. Infrared is heat. Like our military uses infrared goggles, right? Infrared masks or whatever it is, and it's to help see people, right, at nighttime, because people give off heat, right? People give off heat, so you can see movement of people at nighttime. Crazy. All right, some of this outgoing infrared radiation is trapped by the Earth's atmosphere, right? And we're talking about greenhouse gases right here: water vapor, CO2, ozone, O3, and methane, CH4. All right, here's the hockey stick curve. So over the course of years, we have peaks and valleys, right, like a cyclic graph. Sometimes it can be very low, sometimes it can be pretty high. And of late, right, our curve has been moving up and up and up. All right, hence global warming. All right, let's take 2 questions right now. First question says, because Venus has greater atmospheric carbon dioxide (CO2) content than the Earth has, the surface temperature of Venus is. All right. We have A, warmer due to the absorption of long-wave infrared radiation by a greenhouse gas. B, warmer due to the absorption of short-wave radiation, UV radiation by a greenhouse gas. C, cooler due to the absorption of long-wave infrared radiation by a greenhouse gas. Or D, cooler due to the absorption of short-wave radiation, UV light, by a greenhouse gas. All right, so think of an answer, right? Pause it. And once you have your answer, you can hit the play button and you can listen in. Okay? Great, thank you. So Venus has a lot of CO2, much more than the Earth. We know CO2 is a greenhouse gas. And greenhouse gases can help trap in a lot more heat. So it's going to be warmer. So we can eliminate C and D. It's not going to be cooler. And it says warmer due to the absorption of long-wave infrared or short-wave radiation, ultraviolet. All right, so the surface temperature of Venus is warmer due to the absorption of long-wave radiation by greenhouse gases. All right, so the answer here is choice A. All right, and CO2 is a greenhouse gas. All right, trapping in long-wave. Let's go to number 2. Number 2 is a great question. 2, which diagram best shows how air inside a greenhouse warms as a result of energy from the sun? All right, here's your key. You have visible light rays coming in, right? Here's your visible light, and here's your infrared. Notice one's short and one's long. All right, we have choice A, B, C, and D. Take a look at the pictures. Think of an answer, right? And pause it. Once you have your answer, hit the play button and listen in. All right, thank you. All right, so if you look at choice A, we have infrared coming in. Choice B, we have visible light coming in. C is visible light, and D is visible light. All right, C visible too. All right. So based on this, we know that short waves must come in first, right? So looking at your key, visible light is the short waves. So we can eliminate choice A. It's either B, C, or D. So visible light comes into, it has to go into a greenhouse. It must. So we can eliminate choice B, right? Because the visible light does not make it through. C and D does, right? Only difference here is that choice C, the infrared, gets trapped inside, or the infrared escapes. In order for a greenhouse to be warm, right, which is infrared, all right, it has to be trapped inside, right? So our greenhouse gases, like CO2, like in the question before, would help trap in that infrared heat. It traps it, just like how a greenhouse would trap it too. And like your car, going to the beach, summertime, right? Your car is much warmer because the visible light goes through your window glass and the interior would absorb it. And the interior would give it off as infrared. And it has a hard time leaving your car, which makes it a lot hotter than the outside temperature. All right, so the best answer for number 2 is C. All right, here we go. Intellectual engagement. The molecule of CO2 that is put into the atmosphere does not leave the atmosphere for about 50 years, meaning that the CO2 that is being pumped into the atmosphere today does not have its full warming effect until 50 years from now. While cutting or stopping CO2 emissions is priority, drawing CO2 out of the atmosphere is the final goal. All right? How do you think humans can begin to take on this task? All right, so think of an answer, pause it. Once you have an answer, hit the play button. Okay, thank you. All right, so how can we begin to take on this task, right, of cutting CO2 emissions? All right, I drive around a car that's a hybrid. All right, so I drive a hybrid car, and some cars now are hybrid, which means that there's an electric component and a gas component to it. All right, there's cars like Tesla, which is full electric. All right, which is cutting emissions a great deal and cutting CO2. So we need to start cutting our CO2 emissions from cars and from smokestacks and other things too that can help retain this infrared heat, causing the Earth to warm, like in that hockey stick curve. All right, there you go. All right, task for this using what we just learned about greenhouse effect. Visual: create a detailed illustration of how greenhouse gases interact with shortwave and longwave radiation. Auditory: create a news report on climate change, greenhouse gases, and short and longwave radiation in the atmosphere. Kinesthetic: create a table that organizes the greenhouse gases by abundance and explain in a paragraph how they interact with incoming shortwave and outgoing longwave radiation. All right, so tomorrow I'll have you guys work on that in class. All right, summarize today. 3 important things that we learned today, right? One is the greenhouse effect, right? How an actual greenhouse can help with this idea, this concept. All right, we learned about how we have visible light coming in, right? Mainly visible. We do have UV, we do have infrared coming in, but we have mainly visible light coming in. How the Earth will absorb that visible and give it off as a longer wave, right? As long wave radiation called infrared. All right, so again, 3 important things. We learned about the greenhouse effect. We learned about greenhouse gases, right? We have H2O, which is water vapor. We have CH4, which is methane. We have CO2, carbon dioxide, and we have O3 for ozone. And we went over short waves versus long waves. All right, guys, thank you. Please watch this video. Make sure you learn about the greenhouse effect and how that works. All right, have a good night.